Hello, this is Greg Gaussman, Galactic Greg. It's coming to you on the 21st of June, 21. Time on deck, 0300 hours, Central Daylight Time. Scientists have for a while projected that the icy moon of Saturn, Enceladus, may well be one of the top sites in our solar system where we might find life outside of Earth. And now, it just so happens that there's been evidence projected that suggests indeed there may be life there. We may have already found that evidence. And this was revealed to the general public in an article in Popular Science by which they interviewed Charlie Wood. And Charlie Wood depicted the analysis that suggested this. And this analysis is based on one fact. The amount of methane gas coming from Enceladus is much higher than can be accounted for by serpentinization, which is the mineralogical chemical process by which they would expect methane to originate within the crust of Enceladus based on the activity and chemical processes. It's a hydrothermal events. Well, this doesn't prove there's life there, but it's highly suggestive, highly indicative. And in fact, their analysis, they look at things like bacterial analogs on Earth, and they did a lot of Bayesian analysis on this, and they found in their analysis that they believe that life, methodogenic processes, or methogenesis, there's certain bacteria that does this, is the single most probable answer. I mean, it is the answer, but this is interesting because, among other things, Enceladus isn't the largest icy moon out there in our solar system. Europa is believed to have an ocean much bigger than the ocean of Earth. So it may too be a similar site. So we're going to kind of go into this. We're going to look at some of these things that are suggested by this stuff. But this is exciting to say the least. Some of you may not be aware, but Cassini, the recent probe that went to Saturn and flew around quite a while and did a lot of observations before it was ditched into the Saturnian atmosphere, actually flew through one of the icy plumes that comes out of the south pole of the moon Enceladus. Now, for those of you that don't know, I'll show you some pictures in a little bit. The moon Enceladus actually has water jets that shoot into space from its south polar region. It's just constant spewing like oh, fateful, you might say. Now, of this material, a lot of it falls back onto the surface of Enceladus as snow, but a lot of it escapes the moon entirely, which suggests that maybe at one time Enceladus might have been a lot larger, might have had a much larger ocean in it, and it's been slowly petering away, being vented into space for God knows how long. We have no idea how this process has been going on. We don't know how old Enceladus is. We don't know the original composition of Enceladus, and it's possible that there is just natural methane that's coming out. But these are all very, very interesting things that we're finding there. You know, on Earth, you know, our deep sea vents have microbial life and ecosystems, and even complex multicellular organisms. In fact, there are suggestions that life on Earth may have actually began at the hydrothermal vents on Earth, which makes it seem all the more possible that maybe there's life out there at these moons. Of course, some of us think panspermia is the answer to how life got started because life is so complex. How did life wind up on Earth as soon as the rocks cooled off enough for it to form? A lot of big questions about that. Panspermia, for some of us, seems to answer some of that. You know, some of us consider this to be intelligent design. All right. So, as I said, Cassini, NASA spacecraft that orbited Saturn for some time, indeed indicated that Enceladus has a liquid ocean. As I mentioned, it did fly through the plumes, and that plume analysis suggested that it had alkaline hydrothermal vents to boot. Now, see, that's the cool thing, and those would have to be present on the seafloor of Enceladus itself. So these are all further and further indications. Okay, Saturn's moon Enceladus has an ocean. It has alkaline vents on the seafloor. and there's a overabundance of methane. Now there's overabundance of hydrogen gas too, but it could be the hydrogen gas is more present because it's too hot right there near the thermal vent. So some of this is escaping, and the biological activity has to be a little bit further away from the thermal vents. This is what some of the analysts project and believe may be the case. So these are very interesting findings. It turns out that they did, like I said, they did a lot of Bayesian analysis on this. This was done, but one of the guys was Antonian Affolter with the ENS in Paris who did that. And basically, they disqualified most of the processes outside of biological process just because, like I said, there's too much methane. What they found is that the observed escape rates cannot be explained solely by abiotic alteration of the rocky core by serpentinization, which I mentioned earlier, and they're comparable with the hypothesis of habitable conditions for methanogens. Methanogens are the methane-consuming bacteria that I mentioned, and they score highest likelihood for the hypothesis of methanogenesis, which is methanogens making the methane, assuming that the probability of life emerging there from the very beginning is high enough. Well, I would say that's a big question. So, of course, more data is needed for all this. So what I'm going to do here is I'm going to come in here and share some pictures of this stuff with you. We're going to kind of walk through it. We're going to talk about that. I'm going to show some stuff on the hydrothermal vents from Earth and pictures of life there. So we're going to find stuff like that in Enceladus, Europa, Ganymede, Callisto, all these other moons. Let's go have a look and see what we can find here. I'll show these articles. Bang, here we go. This is from Earth and Sky magazine. This is the icy moon Enceladus. I once lived on the ice planet Alaska myself. That's not been another planet. So, yeah, this, like I said, this is considered to be one of the best places for life to form. And we'll have a look at that here in a second. This is the artist's rendition of these hydrothermal vents, and I'll show you some pictures of this, which water is actually escaping from Enceladus. This is thought to be the core, and this represents the hydrothermal vents inside of Enceladus. As you know, moons of planets can be have such tidal forces on them that causes them to be very volcanic, as in the case of the moon Io, or Io, however you want to call it, at Jupiter. Yeah, depends on whether you're Carl Sagan or not as to how you pronounce it, right? So this is an actual photograph here of the plumes, and then some photographs a little more prominent in that. This is Mr. Antonian Affolter. And oh yeah, up here we'll find a picture. I thought he was in here. Mr. Charles Woods, where's he at? Oh, I picture Charles Woods. Okay. Here's what we got. Cutaway artist rendition. I want to show you different depictions of this, and some of them look quite different. This looks like a very thick ocean here, comparatively speaking, to the rocky crust and the seafloor below, but we don't know that. We don't know that. There's just a lot we don't know. This is an artist rendition. I'll show you other pictures here. Water rock reactions, and water rock reactions is the key to the serpentinization process. I'll show you a little bit on that here in a second from another article. Like I said, more data is needed. So we'll come over here and we'll look in this article here. Pull it up. Give me a minute here. Zoom fights me sometimes to click on stuff like that. Okay, now it's coming up. There we go. This is the process of serpentinization as defined by the Oxford University Press, I suppose. The process whereby high temperature primary ferromagnetism minerals and igneous rock undergo alteration to a number of the serpentine groups of minerals. The process is initiated by the introduction of low temperature water into the rock system. These the rocks are hotter like in the thermal vent, right? The water acting as a catalyst for the reaction in the high temperature primary ferromagnetic Magnesium minerals are converted to low temperature secondary serpentine group. Mineral serpentinization is extremely common in ultra basic rocks, especially those found in ophiolites. I'm not a geologist, by the way. Where the entire rock may be converted to a serpentine group minerals forming serpentine rock, where there is the original mineral assemblage that can be inferred from minerals or pseudomorph textures, and the original mineral name can be added to the rock name. The thus a serpentized dunite would be an olivine serpentine. Okay, hey, yeah, that olivine rock is a real interesting mineral. So, wow, that's pretty complex, right? Okay, heck with all that. So let's look here. Many articles about where you most likely would find life. This is from way back in 2012, or 9 years ago. And this article from space.com rated Enceladus at the top. And then Mars. You'll find these rankings vary a lot over time. Titan, Europa, Venus. Yes, Venus. Now here, it's Venus is just right under these others here. Callisto and Ganymede. Why do they rank those together? 6 most likely places. They snuck a 7th in on us, right? Is that what they did there? All right, 10 most likely places to find life in the solar system. There we go. And Europa being number 1 in this ranking. Well, Europa has an ocean much larger than Earth's ocean. And although the moon is only 90% the size of our moon. Now, I'm going to show you in a little bit. You'll be surprised how small Enceladus is. So Ganymede is number 3 here. Ceres, yes, the large asteroid Ceres is thought by many to possibly harbor life. Enceladus is number 5 in this list. Callisto, number 6. Callisto is, the largest moon of Jupiter. It may be underrated, guys. Maybe they think it don't have enough tidal forces in it because it's part of Triton. Triton's a very interesting large moon. Mimas, it's like a Death Star, right? Mimas and also, what's the Saturnian moon? Iapetus. Both look like Death Stars. Mimas and Iapetus. And Pluto. Well, Pluto seems to have a subsurface ocean. And you know what? There's other bodies out there that might be explained this way. So these are not alone, and the rankings change from time to time. Now, this is on the moon Enceladus here. It's an article from Wikipedia. And what I'm going to do is I'm just going to walk you through these pictures. Bing. Isn't that beautiful? There we are, Enceladus. Look at all the rifts and fissures in this ice. That suggests that it moves around. It's been hit by meteorites. This is probably the older surface here. This is probably younger surface. And it's interesting, the older surface is in the North Pole region, opposite from where the plumes fall out, right? Or come out. A lot of impacts, little splotches, different patterns, rebound peaks in the center. And you can see from the orbits here, Enceladus is rather close to Jupiter compared to a lot of the other moons. Check these out. The really large ones are further out than this, like Titan. This is another artist rendition of what's going on here. And trapping of methane in Enceladus' ocean. So this is also showing up in articles here on Wikipedia now, talking about the methane, potential abiotic sources of methane is what it's talking about here. This predates the article I just mentioned that Charlie Woods talked about. Charlie Woods, excuse me, Woods' his last name. And so this would be your, say, olivine plus water. I mentioned olivine earlier. That would be your serpentinization process that you're referring to here. We're just not saying that name, but they did mention olivine. Aha. So here's another depiction. Apparently Enceladus is in this large E-ring, and you got to go further out to find Titan, Hyperion, Iapetus, and Phoebe. So here we go, guys. Mimas and Iapetus, which is further out, both have that Death Star look about them. So Enceladus is down here, okay, guys? Okay. We can see Enceladus orbiting within Saturn's E ring at this point. Yep, that's where it's at. And it may be a major contributor to the E ring. Maybe the E ring came from the off-gassing of water from off-gassing, those hydrothermal vents from Enceladus itself. Now, here's the vents. There's a picture. This is a little bit of an artistic rendition of it, trying to depict the temperatures. A curtain of eruptions. Yeah, so you can see that it's actually, these eruptions are coming out the cracks in the ice. It's like I mentioned, a curtain, like we're trying to show here. This is just to emphasize how these eruptions are actually coming out. They're all over the South Pole, coming out in stripes and strips. On the left side is the brightness enhanced. Okay, hang on. Somehow I got into, well, all right, here we go. That's what I'm trying to do. Get back to this. See, this is the South Pole. It's got strips in which this comes out. Isn't that interesting? The North Pole, not so much. So just for some reason, it's all erupting in the South Pole. Interesting. Our South Pole, capped with ice, has a lot of volcanic activity too. Antarctica is a very volcanic region. These beautiful pictures. Now you can actually see the stripes there, the strips of how it's all ripped up and what's bringing that stuff out, where it's coming from. Beautiful moons, glaciers on Earth. And here's another depiction of how they think this is cycling, circling. There's a picture of it further out. Another picture where it's, you know, you're looking at it from the dark side. Yeah, you know, looks like a crescent moon. That's what it is from that angle. Those jets. So it's constantly spewing water. Enceladus seems to be constantly spewing water. So how long can it maintain its ocean like that? I mean, guys, this may have once been a much bigger ocean. And it may be diminishing over time. It may have once been a far larger moon. Now here's an interesting picture. And here, look, they suggest organics, but they were talking organic minerals, not necessarily organic organisms. Or do they? Enceladus, organics on ice springs, artist concept. We find organic gases. Now see, there's fissures coming up, and this is a depiction of what might be happening in these cracks. So you might find evidence of life directly on the surface of Enceladus or in the E-ring. You might find fossils or dead organisms in the E-ring. Or, you know, some diatoms and other organisms could actually survive there for some long time, perhaps, as we're discovering with things in space. So this is the kind of phenomenology that could lend more credence to the idea of panspermia. And a moon like Pickens, being as small as it is, has a lower escape velocity than a larger moon. Also, the same is true with EOIO, whatever you want to call it, the most volcanic object in our solar system, moon of Jupiter, which resurfaces itself every 400 years. Its volcanoes propel material past the escape velocity of the moon. So that moon also is likely to be diminishing in size over time. Now you can see the methane here, lots of methane. Simple organics, which is, you know, many different molecules. Carbon monoxide, complex organics, and carbon dioxide. And again, these were found by Cassini. And again, as I mentioned, Cassini actually went through the plumes. This is that surface area again. They're showing you the cracks. You can see the photographs of the cracks, and they've laid over it, kind of overlaid a thermal looking image just to depict what's happening there. And this is Enceladus transit of the moon, Titan. So you see, Titan's much farther out, but from the angle that Cassini was at here, you could see them both together. Isn't that cool? Isn't that just cool? Now, to give you the comparison of size, if this is Earth and this is our moon, this is how small Enceladus actually is. Enceladus is tiny for, you know, comparative to our moon. And in fact, this is Enceladus compared to the United Kingdom, you know, the British Isles basically here. And of course, here's Ireland. So, and then now that puts it in perspective. Puts it into perspective. More artist concepts of these geysers. This is over the rings of Saturn. That'd be a beautiful place to go. Could you imagine exploring these moons and Saturn and the rings there? Holy guacamole. That is Cassini, Huygens spacecraft. Huygens, yeah, the European Space Agency was very involved in this. Huygens was the first probe that went down into the atmosphere of Saturn before Cassini itself. No, excuse me. Huygens went into Titan. Huygens landed on Titan, pardon me. Cassini went down the atmosphere of Saturn. Yeah, okay, it's late. It's wee hours of the morning here. So pardon me for my transgression. I'm talking about there. All right, so talking about thermal vents on Earth. They discovered them only in 1977 that they had life down there, the thermal vents in the ocean floor. 1977. I was 17 years old. I was already driving for over a year before they discovered this was taking place. So, and they discovered complex multicellular organisms, including some fish, shrimp, crabs, and other life. But it's interesting that 90% of the life discovered there is like unique. The tube worms there. The tube worms absorb hydrogen sulfide and other chemicals from the vent fluids to feed bacteria living in them. In return, the bacteria provide carbon necessary for the tube worms to live. See, tube worms are a very different life form, because what this says is there was a divergence in the evolutionary path of all these life forms millions and millions of years ago. So you have a lot of life forms there. It's very, very distinct. And, well, I want these tabs advanced. Hang on. Somewhere I've got an article talking about life beginning. Yeah. Deep sea vents ideal conditions for the origin of life. Here's a paper, actually an article talking about these events, and there's actually a number of scientific papers on this too. I thought I had a paper dialed up here, but I guess I deleted it accidentally. So there you are. A lot of people believe that life, from what they're finding, may have indeed began on the seafloor at the thermal vents. And here's a picture of some of the life forms we find down there. There are indeed some fish, some shrimp, octopus, some really strange looking starfish here with a whole lot of legs on it. But the most interesting thing is these tube worms. And they're really not found anywhere else. Lots of tube worms, looks like some mollusks down there. Hydrothermal vent survival. So this is all interesting, guys. There's the hydrothermal vents with the gases escaping. So we find this on Earth. These sites are teeming with life. I was hoping I could blow that up a little bit. Teeming with all kinds and manner of life in those locations, including organisms that are, you know, come from above and got down in there and evolved to live specifically in that environment. There's a translucent octopus. There's a weird looking crab. All crabs aren't exactly directly related. It turns out that the crab form has evolved separately from about 4 different lineages. Isn't that interesting? At least that's what if I recall correctly. Oh, here's our cute guy. Look at that. What is this guy? Wow. Aren't you glad this thing getting 20 foot tall? Or is it? Yeah, it'd give you nightmares if you were a small little bitty thing, right? Oh, got some lovely critters down there. It looks kind of like a water bear, don't it? There's some small critters down there, guys. This is just fun. Lots of interesting stuff on the seafloor at the hydrothermal vents. It is quite alive, and we didn't discover this until I was already 17 years old. Look at these life forms, guys. Aren't they beautiful? Isn't it interesting? It's kind of like a bug there. And there's a crab. Guess that's a crab. Wow, crabs, mollusks, octopus, but these tube worms and other life forms there that aren't like anything we know of are the most prevalent. I just want to get this picture blown up. I want to see that one larger. Well, new deep sea hydrothermal vents, life forms discovered. So we just keep finding new things, guys, down there. So the oceans are quite a frontier. Let me stop the share here. The oceans are quite a frontier on Earth, and it may be a frontier throughout our solar system and beyond. And it could be that the most likely place that life may have formed and began is hydrothermal vents of ice moons. And, you know, it doesn't take as big a collision hitting an ice moon to knock it apart. We can see that they've taken some big hits like Mimas and Iapetus have taken large hits. And some people believe those moons shattered and then kind of come back together under the gravity. And a lot of material might have escaped during an event like that. And it might have escaped under temperatures that weren't as great as like an impact on Earth. And as we see, ice moons like Enceladus are already spewing, and Io also already spewing materials into free space, at least around around Saturn for Enceladus, and around Jupiter for the moon Io, which that's what it's taken like that. I always prefer to call it Io though. Input output. Seems to be more in the area of output than input. So there we are, guys. These ice moons are very interesting. We need to pay attention to them. Hopefully we'll be out there and exploring them maybe in our lifetimes, and we can find out if something's there. Hey guys, get your poles and let's go fishing in the stars. Who knows? I'm not saying there's life there, but it is interesting. It is interesting. Guys, I really appreciate you for watching. Please subscribe to my channel. Bang the update notification bell and click all. I need more subscribers. Share my videos, guys. We need some more help growing this channel. Thank you for watching.